Machine learning is a fast-growing field, and researchers are quickly developing new algorithms to better address some of the most pressing issues in our society. However, to put these new, advanced machine learning methods to good use, we have to develop machine learning systems that can process and learn with massive amounts of data quickly. My project, Parallelized Parsing for Fast Machine Learning Systems, focuses on ways to make the Valpal-Wabbit machine learning system faster and to help it better utilize resources by leveraging the benefits provided by parallel computing. Let's introduce the bare bones of a machine learning system, which provides the technical framework to run a machine learning algorithm on some input. The system will read in an input file. It first must process this input file into examples, or in other words, the data that will actually be used by the ML model itself. Then, it finally runs an ML model on these examples. We ask the following: what if the input file is actually enormous? For example, if we are a big technology firm trying to learn from our customers' data, we may have billions or trillions of lines in our input file. If the file is enormous, it will take a long time to process the input file into examples. This is because this processing step requires reading every line in the file and parsing it into an example. This limits the usefulness of the system and blocks the use of new ML algorithms. This is because even if we have a very useful and efficient machine learning algorithm with lots of power, we won't be able to get a fast result if the system takes forever to process the input file. We see now that the impact of speeding up this processing step is that the whole machine learning system gains a lot more utility in different applications. For example, it could allow a video game designer to design faster games, or for a researcher studying patterns in genomic data to run their system quickly. This project helps to improve and speed up this input processing step for the Valpal-Wabbit machine learning system. Valpal-Wabbit is a machine learning system that pushes the frontier of machine learning techniques. It is known for its incredibly fast system and is widely used in the technology industry. There are many reasons why it's essential to speed up the previously slow input parsing step of Valpal-Wabbit. First, it allows researchers pushing the frontier of machine learning techniques to try out new algorithms on large amounts of data in less time. Second, since its use is widespread, countless customers are relying on Valpal-Wabbit to be fast, reliable, and to explore new avenues to improve their system. This project improves the input parsing component of the machine learning system using parallel computing. Our computers have multiple cores used for computing. Parallel computing allows us to execute different tasks simultaneously using multiple concurrent threads on multiple processor cores. This can speed up our system and allow it to better utilize resources. The previous structure of Valpal-Wabbit looks something like this. The system took an input file, processed and parsed the input, and sent it over to the ML engine. This project converted the structure of Valpal-Wabbit to a new structure that has many threads running simultaneously, each parsing in lines of input and sending constructed examples to the ML engine. This will speed up our system very noticeably. To measure the performance improvement gained from this project, I took measurements of the runtime of Valpal-Wabbit systems before and after my changes. I found that the use of parallelized parsing contributed to a 34% improvement in the runtime of the machine learning system overall. That is, if we run the system now, as compared to before, we take only 66% of the time we used to take. The following diagram plots the runtime of Valpal-Wabbit when different numbers of threads are used. The flat line represents the baseline runtime of the previous system setup. The pink line is the measurement after the changes from this project have been made to the system. First, to acknowledge the increase in time for a low number of threads. This is both natural and expected. It occurs because this process adds additional steps, and our low thread count tests won't use parallelization benefits of the project. The solution for this is to use the old code structure for one thread. For 4 to 6 threads, we see that the new system runs at approximately the same time as the original system. Since this project improved the design of the parsing component of the system, we already have some sort of benefit for an intermediate number of threads. Lastly, for 7 or more threads, we see that the new system runs in 66% of the time of the original code. In other words, we see a 34% improvement in the system's performance. This is a clear measure of the impact of this project and the utility it can provide in helping push the frontier of fast machine learning. Now, we will discuss the impact of this project more broadly. First, this project helps improve and advance the technical framework for a machine learning system that can accelerate research in machine learning. Since Valpal Wabbit is a system not only used by customers who need fast and reliable machine learning, but is also used by researchers to develop and test new cutting-edge algorithms, ensuring that the system scales well and quickly to large amounts of data is essential to helping the researchers test out algorithms at different levels and on different datasets. Second, by parallelizing the parser and allowing for Valpal Wabbit to have a runtime reduced by up to 34%, this project benefits customers who rely strongly on their machine learning system to run quickly. This enables customers, companies, and engineers to create more innovative products and solutions using machine learning. Lastly, since this project provides a proof that the concept of parallel computing can provide utility in the parsing component of the Valpal Wabbit machine learning system, this project helps to inform experimental technical decisions and further the way in which backend optimization can be used to improve machine learning systems. Thank you so much for listening to my presentation and for your time and consideration.